Solving systems today. We did it last time, but today we're going to use matrices to solve systems. But a little fact, Jack, you can only use a matrix for linear systems. If it's quadratic, cubic, like non-linear stuff, you cannot use a matrix. So number one, this question is probably the most missed one on our test because students think they want you to solve that system. They do not want you to solve that system. They want you to write the augmented matrix. It's been a couple of years since I taught Advanced Algebra 2, but back when I used to teach it, I was big on telling some kids the difference between an augmented matrix and the solutions matrix. This is the augmented matrix. This is all you got to do. Remember, a matrix is basically like a spreadsheet. By the way, if you have never seen matrices before, I'm going to go kind of fast today, and I will help you later punch stuff in the graphing calculator, right? But I'm going to go quickly. The augmented matrix is just this. Remember, these are like your x's, these are your y's, these are your z's, and then like here's your constants. You don't need to write this above here. I'm just kind of going to show you what's up. But there's 1x, 1y, a negative 1z, and 4 constants. I do like that green up and down guy to show you where the equal signs are, but you see how I just put the coefficients of each guy in that case. So there is 1x here, minus 2y's here, negative 1z here, and then negative 2 constants. And then finally, booyah. That is the answer to this question. You do not punch anything into your calculator to compute stuff because that is finding the solutions matrix. An augmented matrix means, hey, get rid of all the letters and make it like a little spreadsheety type thing, you know? So that's the augmented matrix. Are we okay with that? All right, so number 2, now do you see they say find the solutions? Here's what I suggest. I suggest that we write an augmented matrix off to the side. I'm not going to force you to, but I suggest that we do. So this, I would go with 1x, 1y, negative 1z, and 0 constants. And then just rocking and rolling through the rest. But I won't lie, this is an option for you. If you don't want to do that on the test, I ain't going to be mad. But you do have to use that to do the solutions matrix. So it may have been a while since you've done it. Let's just say you got your calculator going right here. How do you get to matrices? There is it's in a second function. You hit second matrix. It's right above the x squared button. And I already have a couple of matrices typed in my calculator. You may not, you know, based on if you have a brand new calculator or not. But what you got to do is you just scroll over to the top window to go to edit. And I didn't really explain, but are we cool that this is a 3 by 4 matrix because there are 3 rows right here with 4 columns going up and down. So I'm going to make a 3 by 4 matrix. Sorry, I went the wrong way. If I could just open my calculator. I'm going to go to my 3 by 4 matrix. But if you don't have anything typed in, you have no matrices whatsoever, you just need to type a 3 in this spot right here and a 4 in that spot right there. And then you literally just type in your augmented matrix. It goes from left to right. And again, if you have never done this before on the graphing calculator, be patient. I will help you individually. And I also appreciate your patience. It takes me longer to type in on my computer here. Oh, man. See, I already messed that up. Now that I have successfully fixed it, always double check that you like totally get your matrix typed in right because the calculator is going to do all the work. But people are like, man, I totally forgot what to do after this. So what you do is you have to quit out of it. So hit second, quit. You just quit out of your matrix. And then you got to go back into the matrix menu of hitting second matrix again. But see, we have like entered the matrix in the calculator. So now what we want to do is move that black bar at the top over to math. And then the option that we're looking for is called reduced row echelon form. I don't know if your math teacher taught you that or not, but it's option B as in boy. So like getting there, you can either go up or down. It's that RREF. I'm fine if you don't remember that it's called reduced row echelon form. If you just know that it's option B, the RREF, that's good for me. Right? So I'm hitting that. And your calculator's just sitting there going, okay, you want to do reduced row echelon form, the cursor's just flashing. You have to pick a matrix for it to do it. So you got to go back to second matrix. And in my calculator, it's matrix B. So I moved my little black cursor down to B. Yours might be in matrix A, but I did that. And this right here is what we're looking for. That is called the solutions matrix. I require you to write that down. If you solved with a matrix, you must write the solutions matrix down on paper. And here's what we're looking for. This is the point of the day, because we could be done with this after 2 questions, but sometimes there's one solution, sometimes there's infinite solutions, and sometimes there's no solution. So like just reading the matrix for itself, what you're looking for is a row of 1s going diagonally like that, and everybody else's zeros on the left side of the equal sign. Are you with me on that? So this means there is one solution to it. So you'll write your answer as an ordered triple. 3, -2, 1. This literally says x equals 3, 1y equals -2, and 1z equals 1. And just because I'm awesome, have you ever seen that graphed before? When you graph something with 3 variables, it makes a plane. And I have graphed all 3 of those guys right there. So if you look up here in the upper left, those are those 3 equations. And do you see that those 3 planes just intersect in that one point right there? That ordered triple is at 3, -2, 1. And for those who are into computer graphics, that's how 3-dimensional images are made. You have an x-axis, a y-axis, and a z-axis, length, width, and height kind of stuff. So I understand you might not think this is very important for you. Graphical design people do a lot of 3-dimensional stuff, you know what I mean? So there's a lot of cool graphing stuff there. So cool. Let's do another one, man. Let's write ourselves an augmented matrix. And here's the problem. Look at this dude. I think we know what to do, though. That dude doesn't have all the letters, right? He's only got x's and y's, so we got to fill in a placeholder. So in this first dude, there is a 3 x's, -2 y's, 5 z's, and then 15 constants. 1, -2, -2, -1. And what should I put in place of the z's? Like, since there are no z's, we only put a 0, right? You'll put none of them there, and you just got to make sure you put him in the right column, right? He's in the z position. Cool? So let's put that into our calculator. And then maybe I'll show you something you've never seen before, but I hope your Algebra 2 teacher showed you a shortcut here. I got a shortcut for you. So I got to go back to edit my matrix, 3 by 4. And you got to just get down in here and make sure you type everybody in right. If you get really weird answers, the first thing I do is go back and see, did I even put the right numbers into my matrix? Maybe I made a typo. Cool, that you've entered the matrix correctly. Quit out of it, and maybe you've seen this before, or maybe you have not. Would you believe that the previous entry that I have done in my calculator is reduced row echelon form on matrix B? It's like literally sitting right there. It's like, hey, that's what I did last time. That's what I want to do again, right? So I don't need to go through all that rigmarole. If I hit right above the equal sign is in blue, it says entry. If I hit second entry, it's like, oh, you want to just do the same entry again, just repeat it. And what we've done is we've changed matrix B. That's what we just did, so you don't have to go through and do that. Did they show you that before? You know? So yeah, anytime you want to do a previous thing, it's like, hey, I just did that. You know, cool. Would you be down with the fact that we totally changed matrix B, though? So write your solutions matrix down, and then we've got to interpret it. Do I have one solution, no solutions, or infinite solutions? If you get a row of 1s going diagonally and everybody else is 0s, there is one solution to that. What do you think? One solution. What I want in the answer blank on the test is the solution as an ordered triple. You know, it's x, y, z. Boy, I'm struggling because I'm trying to go fast. But x, y, z. Cool. All right. Now it's obviously time to do some no solutions and infinite solutions in this. So let's rock and roll. Get you an augmented matrix if you want. And let's see what happens when we put it in. So I got her all typed in. I'll quit out of it. I would like to do reduced row echelon form on that guy again. So all I have to do is hit like second and then the equal sign, which is like for previous entry. And then you see it. Those aren't the worst decimals in the world, but sometimes they're going to be nasty. I don't want decimals. I want fractions. Do you know how to change a decimal to a fraction on your calculator? What do you hit? Math, enter, enter. Do the same thing, and it'll change that into fractions for me. So, boom, you get that. To read this matrix, I do not have the row of 1s going diagonally on this. So it's either no solutions or infinite solutions. So how do I tell? I just read this little box right here. because there's an equal sign right there. That says 0 equals 0. Yes or no, does 0 equal 0? Yes. So that is infinite solutions. And then we got to put in the form of, right? So here's what I do. I just literally write this. X, Y, Z, and Z, if I could write, equals. Here's what we do. For the infinite solutions, you just got to understand that you're going to let Z equal Z. That happens every time. If you let Z be 5, 5 will equal 5. If you let Z be 7, 7 equals 7. Couldn't that happen an infinite number of times? How did I know to let Z equal Z? He's the only letter that didn't have a 1 by it. Do you see there's a 1 in the X column, there's a 1 in the Y column, but there's no 1s in the Z column. So that's the dude that you're going to let be infinite every time. And then what you do is I'm just going to kind of like write this over to the side. I don't care if you do or don't. What does this 1 mean in this equation right here? What's that 1 mean? 1 what? 1y. Then there's minus 11/8 z's, right, equals 1/8. Isn't that literally what that row right there says? I just want to solve it for y. I want to get y all by itself. Wouldn't I add 11/8 z over to the other side? So y will equal 11/8 z plus 1/8. And I just did that work over here, but I wanted to do it right there. 11/8 z. If you cross your z's, you'll be less confused so they don't look like 2's, plus 1/8. And then you do the same thing in this top row. This is x equals 31/8 z plus equals 11/8. So don't you just need to subtract that dude over? Shouldn't x equal negative 31/8 z's plus 11/8? That's really weird. Especially the first time you saw that back in Algebra 2, you're like, hold the phone here, Batman. But we're going to practice that a couple times and get a little bit better at it. So our final answer will be infinite solutions in the form. And this is why I wrote that up here, because I want to write an ordered triple in terms of z. Everything in here is just going to have z's. No more x's, no more y's. But in the x position, are you down with the fact that x equals negative 31/8 z plus 11/8? So that's what goes here, negative 31/8 z plus 11/8. That's what x equaled. Y totally equaled 11/8 z plus 1/8. That's what y equals right here. And what's shocking is the most missed thing is what z should equal. A lot of people put 0 there. Z does not equal 0. What does z equal? It's z, right? You know, that's the thing. So after we do a couple more of those, people really are like, okay, I see what's going on, but they just, for some reason, they put 0 or 1 in that last spot. Z equals z. Infinite solutions. All right, let's try one more of these bad boys, I think. Maybe two. We might need to skip the next one. I don't remember. Let's try this guy. Put him in. Let's see what happens. All right, I punched that in for you guys. Now I'm going to quit out of it. Ah, crap. My previous entry doesn't say reduced row echelon form on matrix B anymore. So you could go through the whole rigmarole, but watch this super trick. If I hit previous entry, it's going to say, hey, change your answer to the fraction. But if I hit it again, it's like, oh, you want your previous entry? You know, my previous entry was reduced row echelon form on matrix B, so I can do it that way in that case. And I got a this, right? I got a this. What I'd like you to decide with your neighbor, is there one solution to that, no solutions to that, or infinite solutions to that? What's really important to me is you knew there wasn't one solution, right? And people are like, I don't remember how to tell if it's infinite solutions or no solutions. Read the orange box. Read the corner sometimes. That says 0 equals 0. Yes or no, does 0 equal 0? So that is infinite solutions. Did I write it down wrong? Sorry, everyone. So here's what we got to do. See if this second time is nicer, especially since there's no stupid fractions. What do you want to let z equal in the infinite solution? Z should equal z. And all that happens, dude, is the dude that doesn't have the 1 with it needs to move over to the other side of the equal sign. That is a minus 4z. Like, isn't he in the z column? So over here, to move to the other side, doesn't he become a positive 4z? And see, there is a minus 5 right there. So if we do the same concept here, this is about x's, this has to move over to the other side. It's a minus 5z, he will become a positive 5z, and the minus 1 is still there. So writing all that out, infinite solutions in the form, and I just say to myself, x, y, z. But whatever x equals, you put in that spot. X equals 5z minus 1. Y equals 4z minus 5. And z equals z. Weird, 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 weird stuff. Cool. What do I got next? Practice ones. You don't have to write anything down. Just practice. Tell your neighbor, if you got that coming out of your calculator, does that say one solution, no solutions, or infinite solutions? This is infinite solutions, right? So here's what I want you to do. One at a time. First, tell your neighbor what you'd let z equal. What would you let z equal? Z would equal? Z. Now tell them what y would equal. Move that minus 2z over to the other side. Yeah, so more than just 2z, though. 2z what? Plus 3. And then what would x equal? Negative 7z plus 4. Do you see how you're just moving that nugget over one at a time, right? And we haven't done any of these. What if you got that? One solution, no solutions, or infinite solutions? Because you got 0 equals 1, which is not true, right? So that is no solutions to that. Cool? But then, watch out for this on your test. Excuse me, I didn't mean to cough right there. Here's a different matrix. First question, is it linear? Like there's no squares or cubes? So let's use a matrix to solve it and see what happens. So let's go to second matrix. And this is a 2 by 3 matrix now, right? There's only 2 rows and 3 columns, so we'll do that. Negative 4, 6, 12, boom, 10, negative 15, negative 30. Make sure you typed it in right. Now I got to start all over again, so I'm going to quit out of it, go second matrix, math, select option B for reduced row echelon form, but I've got matrix A. And if you have a brand new calculator, I think having those 2 selections in there, that's all we'll ever do is 2 by 3 matrices or 3 by 4. Like leave them both in there, you know what I mean? But you get this. And you didn't deal with that a lot back in your advanced algebra 2 days. You're still reading diagonally for ones going everywhere. You don't have that. So what is this? One solution, no solution, or infinite solutions? This is infinite solutions. But I can't use z's, dude. So who's the guy that doesn't have a 1 with him? X's or y's? So we'll let y equal y, and then you solve this for x, right? And that would be 3/2 y plus 3. Do you see it's the same concept with different letters? Thank you. Minus 3. Cool with that? Minus 3. Are you okay with that? Infinite solutions in the form of 3/2 y minus 3, comma, y. You could also literally solve one of those for y and write it the other way around, but that's just what happens. Hey, that was just a nice refresher. Now let's get to the story problems. Welcome to Fonny's Nightmare. I'm not joking about defining variables. Please pay attention. I know it's Friday afternoon. I need you to read that one to yourself, though, for me, please. When they mixed these things together, do you see you have 3 different percentages that they mixed? And without even reading too detailed, I automatically know which ones they mixed together. Why does it have to be 10 and 5? 10 is the high and 5 is the low. And shouldn't they mix together to be something in between? Are you with me on that? So those are the 2 guys that got mixed together. So what we'll do is, yes, you will define variables accurately. What is this stuff that they're mixing? CC's of some sort of solution, right? You know? So we'll do this. We'll let x equals the number of CC's of 5%, and y equals the number of cc's of 10%. And I can appreciate you trying to take a shortcut. You will get counted off for the shortcut. You can't say x equals 5% and y equals 10%. That is not what it is about. So we are mixing together some of the cc's. And again, how did I know it was those two? One of them was the high and the other one was the low. Are we okay with that? The other thing is the weirdo number, though, is this guy. Do you notice he did not have a percent with him at all? That is how much they totally mixed together. Back to my visual aid, that was 4 ounces. You know, like I put 2 ounces of this and 2 ounces of this, it adds up to 4 ounces. Are you with me? That's like the total amount. So the first equation is usually the weirdest one to think about. I want to just mix it together. And if I ask how many cc's of the 5% did they pour into the cup, people usually go, I don't know. And I go, I know you don't know. That's why we called it X. So how many cc's did we mix in there? X, right? And if you add that to how many cc's of 10% you put in there, could you tell me how many cc's of 10% you put in there? Yeah. It's Y. Like, didn't you just add them up, right? What should they add together to be? That's 100. This is cc's plus cc's equals cc's. And if you know about cc's pizza, that's getting you hungry right now. But like, all the cc's of the 5% plus all the cc's of the 10% add up to be 100 cc's. The second equation, oh, by the way, why we can't just solve this equation by itself, because it's got x's and y's with it. So we need a system so we can cancel some stuff out. So what we'll do is we'll put the percents. Please be careful. What's 5% as a decimal? It ain't 0.5. It's what? Yeah, we all know that. Just watch yourself. It's 0.05x plus 0.10y, and yes, you don't need the 0 at the end. You can call it 0.1y. But watch the trick. We all kind of see that we need the 0.08, but because it is a mixture, you need 8% of the total amount. Like, isn't this 5% of the 4 ounces of water that's in here, right? So you have to take the 8% times the 100, because you had 100 cc's of this fluid that you're putting in the cup. Is that kind of okay with you? Cool. They want us to solve this system by any method you want. You could use elimination, you could use substitution, you could do it graphically, or you could do a matrix. And I say if you're given the option it's linear, you should do a matrix, because it does all the math for you. You know what I mean? So let's do a matrix. This is a 2 by 3. So this is a fancy one. If you remember doing linear programming, these are similar questions. Is this a mixture one? No, it is not. You don't have percents with it. That's usually like 99.9% of the time. If there's percents, we're mixing stuff together. So when you read that, yes, this person's on a special diet, and it's a fancy schmancy way, but hey, there's plenty of people in this world who are on special diets. You know, they're gluten-free, they're this, they've got diabetes, they have to eat this much, they have to take these many pills a day. So, like, I know this is kind of a ridiculous story, but still. Who are the 4 major players as, like, variables in this situation? Shout them out. What's going on here? We got protein, right? Skim milk. What's some other stuff? Iron, and one more. And lean meat, yeah. Okay, so check it out. How do you know which ones are your variables? It's old school algebra. They literally ask you in the question, right? Don't they want those things to be found? So we will define them, and we'll do it accurate. I don't care which one's X and which one's Y, but it's not just milk, it's skim milk, and it's by the glass. And then the 1/4 pound servings of meat is the other variable. But what them other major players are is what your 2 equations can be. Because isn't there something about iron and isn't there something about protein, right? So that tells you that you're going to need an iron equation and a protein equation. So I don't care if you write this down or not, but some people like it. I'm going to write an iron equation right here. So if I read through all of this stuff right here, it says a glass of skim milk provides 0.1 milligrams of iron. Sweet. Are you cool with, I could call that 0.1x, because a glass of skim milk is what X is, and it had 0.1 milligrams of iron. Plus, okay, 8 grams of protein, don't care about that, we'll do that later. But if you have that lean meat, don't they get 3.4 milligrams of iron for every piece of quarter-pound serving of meat, so that's times y. And do we know a total amount of iron this person is supposed to eat every day? Do you see everything in there was iron? Iron plus iron equaled iron, right? Iron plus, see if you can write a protein equation below that. Protein equation. And that's what I got. There's no mixing going on whatsoever, so it's just 8.5 grams of protein for every skim milk, 22 grams of protein for every quarter-pound serving of meat, and 69.5 grams of that. While you're doing the matrix, people ask a good question. Does it matter that one of them's in milligrams and the other one's in grams? It doesn't, because all of the iron was in milligrams. It was milligrams, 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 and all of the protein was in grams, so you don't have to do any converting there. All right, so you can punch that into your matrix and see if you get the same thing I got. 3-2 or 2-3? Which one is it? Is it 3-2? See if you get that. So 3 what? Glasses of skim milk and 2 quarter-pound servings of meat. What a diet. And I'm just trying to let you know I'm serious about the labels, right? So don't be mad at me on test day if you're like, you took off points for this. Like, yep, accurate labels, put them in the question also. Okie dokie dokie. One more. We'd stop if it wasn't a weird one, but we'll do the last one. But I'll let you read it. So you can kind of see that you got all these cool dudes right here. Some of them show up like twice, you know. But I got all those, but this guy in green is different. Don't all the orange ones have dollar signs with them, and the green one is not about dollars, right? But it's still not a mixture problem because there's no percents with that. It's about the theater selling out. And go to the question to see what you should define your variables to be. It says how many of each type of seats should they have? How many different styles of seats are they selling tickets for? 3, so that means 3 variables. It doesn't really matter which one, but it's about the number of tickets. I already know the price of the tickets, dude. The $40 seats cost 40 bucks. You know, it's like I know the prices. I want to know the number of the tickets. So we'll define that very nicely. I usually just go in the order that they wrote them in. And while you're writing all that down, here's the secret. 3 variables means you need 3 equations to get this done. And some equations are pretty simple and some are not. So here's what we'll do. What is this 3,600 all about? Total number of seats. So shouldn't all the $40 ticket seats, the number of those, plus the number of the $70 ticket seats, plus the number of the $100 tickets seats, like add up to be 3,600. So that is x plus y plus z equals 3,600. X is all of your $40 seats. Z is all of your $70 seats, and and etc. You get the point. But you also see that that equation is awesome because it's in the order that the matrix should go in. It goes x, y, z equals number. You know, like we're going to use a matrix for this, so that's a good equation. Then I'll bet we can do a good equation with this dude also. Isn't that 192,000 like how much money they're getting, right? So we'll throw the money next to all these bad boys. $40 for every $40 seat, plus $70 for every $70 seat, plus $100 for every $100 seat. If we sell all out, $192,000. Biggest typo that happens is the number of zeros on 192,000. Watch that you type it in correctly, right? But it's that third equation that is the struggle bus for a lot of people. They have to be mathy about it, and they put this in there. He wants to have twice as many $40 tickets as the other types of tickets. That they want twice as many $40 tickets as the sum of the other 2 types of tickets. I can't even put that underneath here because it's not going to line up for the matrix. But So $40 tickets is what they're talking about, the sum of the other two. I'll bet we're really down with the fact that we're going to have to add y and z together, right? So then, my question is this the right equation, or is this the right equation? Talk about that with a neighbor. Which one of those do you feel should be correct? So the correct one is the purple guy, because you have to add these together first and then double it. Well, that ain't going to fit in the matrix worth of crap, so I'm going to distribute the 2 through. 2y plus 2z. This is where crossing your z's really helps. You can tell the difference between your 2's and your 3's and your z's. And this still doesn't fit, so what I'm going to do is subtract all this stuff over. I need x minus 2y minus 2z equals 0. Do you see how I subtract that over, so I can put it in the order for the matrix? And that will work. The other possible thing you could do is this equation is the exact same thing, negative x plus 2y plus 2z. If you happen to have this dude right here, he's the same thing. It's just all times negative 1, so it would still work. But solve that with a matrix. What if you don't own a graphing calculator to do matrices for your homework? In every homework question today that needs a matrix, I have this. So you could hit new matrix, and they called it A. You have to decide how many rows and columns it is. So this is going to be a 3 by 4 matrix, so I had to hit the little plus buttons here. Then you literally just type stuff in. So you had 1, 1, 1, 3600. And then you had 1, minus 2, minus 2. Doesn't matter what order the matrices are in either. 0. And then you had 40. And 70, and 100. Punching it in ain't a big deal, but when people are like, I don't know how to do the rest of it, so I got my matrix punched in. You got to hit enter right here on this blue button, so enter. And then it gives you the option for reduced row echelon form right here. Hit it, and then you got to say, okay, matrix A, because that was the name of that dude right there. So it will literally do the matrices for you. I put that inside of every question that you could use it. So if you don't have a graphing calculator, you could do that. You started out again with new matrix, and then it gave it a name. Now that I'm done, you could go back up and just like totally keep changing and editing that stuff right there. So let's get some homework done, eh?